Hello, everyone. We are back again to our math journey, and I hope each and every one of you is doing great. If you haven't subscribed to our channel, I'd like you to do us a favor by subscribing, liking this video, and sharing. Today, we are going to be looking at how we can practice some questions on indices. Also, before we continue, if you have specific topics that you would like us to discuss on, you can feel free and leave them in the comment section below. And feel free to leave any comment. We welcome any suggestion and any comments. All right, today we're going to be looking at practice questions on indices. So let's start off with this problem right here. Imagine that you have 4 exponent 3 or 4 to the power of 3. Now remember, we did mention that the 4 here is the base. If you remember, that's the base. And then we also said that the one on top is the power or the exponent, if you could remember. All right, so we're going to start off with an equal to sign. We have 4 whole number, 4 exponent 3. So what we do here is that because 4 is the power of 3, it means that we're going to multiply 4 3 times. We're going to multiply the 4 3 times. And you remember, if you remember from this one can be written as 4 to the power of 1 multiplied by 4 to the power of 1 multiplied by 4 to the power of 1. And since this base, that base, and that base are the same, we add the exponent. So we are going to have 4 whole number 1 plus 1 plus 1. And that's how come we get 4 exponent 3. So we're going to continue from here. We're going to have equal to 4 times 4 times 4. And we know that this is 16. 4 times 4 is 16. We drop the multiplication sign and we multiply by 4. And we're going to get 64. How do we get 64? This times this is 24. And with 24, we write the 4 first. And then there's a remainder. There's a remainder of 2. And then this 4 multiplies the 1 here. And then that becomes 4 plus the remainder of 2. So 4 plus 2 becomes 6. So it's 64. So the answer is 64. I hope this one, I hope it helps. I hope it helps. I hope it helps. Okay. We are going to also continue with another one. But before we do that, I want to wipe off the board. And then we can continue from there. All right. I hope you are enjoying this journey together with me. I hope you're enjoying this journey with me. All right, let's look at the second problem. Let's say you have a fraction. The numerator is 1. And in the denominator, you have 2 whole number to the power of 3. 2 whole number to the power of 3. So what do we do? Remember what we did. So what we can do is that we're going to have 1 divided by 2 multiplied by 2 multiplied by 2. I hope you agree. If you remember from the last problem that we did, if you remember from the last problem, we can express this as that. Okay. So we're going to have 1 divided by 2 times 2 times 2. And we know that these 2 is 4. So you're going to have 1 divided by 4 multiplied by 2. And you have 1 divided by 8. So the answer we get there is 1 over 8. I hope you're enjoying what we are doing so far. Now let's look at the third problem. Let's imagine that we have 2 whole number, exponent 5 or to the power of 5 multiplied by 2 whole number to the power of 3. Now, if you remember from our laws, we did mention that this base and that base, they are the same, if you can see. They are equal. And also the operator or the mathematical sign there is multiplication. And because the sign is multiplication and the bases are the same, we are going to apply the rule. We're going to apply the rule that says that we're going to add the exponents. We're going to have two whole number. We're going to add 5 and 3 together. We're going to get 2 to the power of 8. What this means is that you're going to have 2 times 2 times 2 times 2. This is 4 of them. 1, 2, 3, 4. But we want it 8 times. There's 2 times 2 times 2 times 2. Now, this gives us 4. That gives us 4. This also gives us 4. And that gives us 4. And don't forget the multiplication signs. Now, we know that 4 times 4 gives us 16. And this also gives us 16. I think the answer is 256. But we're going to look at how we arrive at that, 256. We know that if you have 16 multiplied by 16, you have 6 times 6 is 36. We write the 6 down here, and then this is the remainder. 6 times 1 is 6. We add it to 3. We have 9. Now we have 1 times 6 here. You get your 6. 1 times the 1, you get your 1. Then you're going to have 6 here. 15, 5 plus 1. Have your 2. So that's how come we get 256. I hope this helps. All right. So I'm going to wipe off the board again, and then we're going to continue. We're going to continue from where we are. All right. But I hope everything is becoming clearer for you. All right. Let's continue with another problem. So there's a problem here. We have x exponent 10 divided by x exponent 4. I don't know whether you can remember. We can rewrite this as x to the power of 10 in the numerator, and in the denominator you have x to the power of 4. And then we're going to apply the rule. Now remember that because the bases are the same, the x here is the same as the x there, we're going to subtract the powers. So we're going to have x to the power of 10 minus 4. Do not forget the rules. If you've forgotten the rules, you can revisit our video on the laws of indices, and I think it will do you good. It will do you good. It will do you good. All right. So we're gonna have x to the power of 6, and that's gonna be the final answer. Now let's look at this one here. Let's say imagine you have x to the power of 10 divided by y to the power of 4. We are saying that we can rewrite this as x to the power of 10 in the numerator, and in the denominator you don't have y to the power of 4. Now here we cannot do anything. We cannot do anything. We cannot do anything. Why? Why? Because this x here, the base here, is different. Because the bases are different. The bases are different. And if the bases are different, we cannot continue. There's nothing else we can do. We can't do much. We cannot do much about it. We cannot do much about it. So there you have it. We're going to continue with other problems. We're going to continue with other problems. And then we're going to continue with other problems. So we have 4a to the power of 3 multiplied by 7a to the power of 2. To the power of 2. Now, you know that, we can, this is the same as saying 4 times a cubed. I don't know whether you can see that. Multiplied by 7 times a squared, or a to the power of 2. Now we can see that these two are the same, so we can bring them around together. So we're going to have 4 multiplied by 7. This is 4 times 7. Multiplied by a to the power of 3. Multiplied by another a to the power of 2. I hope this is clear so far. Now we know that if we multiply this, we're going to get 28. And if we, because this base and this base are the same, we'll multiply by a to the power of 3 plus 2. So we're going to get 28 times a to the power of 5, which is the same as 28 a to the power of 5. Okay, so don't forget, the key thing here that you don't have to forget is that if you have xy, it means x times y. In mathematics, times can be a dot, or x times y. If you have, let's say, a, b, c, in math, it is the same as a times b times c. So I'd like you to keep that in mind. Keep that in mind. All right, let's do this last problem, and then we can maybe end here. The last one, we have 21. Oh, should I wipe the board? I think I should do that. We have 21 to the power of 9 divided by 7 a to the power of 2. So we have 21 a to the power of 9 divided by 7 a to the power of 2. So here, what we're going to do is to rewrite this again as 21a to the power of 9 divided by 7a to the power of 2. Now, this is the same as 21 times a to the power of 9 divided by 7 times a to the power of 2. Now, we can rewrite this as 21 times a to the power of 9 divided by 7 times a to the power of 2. Now, you can see that this 7 has a common factor. It has a common factor with a 21. So 7 will go into itself by 1, and it will go into 21 3 times. And then we're gonna have 3 times a to the power of 9 divided by 1 times a to the power of 2. Now, because this base and that base is the same and they are being divided, we can subtract their index. So we're going to have 3 divided by 1 times a to the power of 9 minus 2, which gives us 3 times a to the power of 7, which is the same as 3 a to the power of 7. All right, we're going to end here for today. We'll come another time and then continue. But if you haven't yet subscribed, please do us a favor and subscribe. Like this video and share it to as many people as possible. And we welcome suggestions and comments. If you have a specific topic you want us to treat, feel free to drop it in the comment section below. All right, I'll come to you another time. Take care. Bye.